All right, so here we go. Going to talk all about just subtracting fractions tonight. And this is, in some ways, if I can click on something here, in some ways, this is, should be, if you're starting to get adding fractions, this might be an easier night, okay? If you're struggling with adding fractions, this will be in some ways a review of how to do that because it's the same steps. And so hopefully we'll kind of catch both groups tonight. Um, so go ahead and take a moment and I'll just give you a minute here to copy down what you see on the screen. Okay. In review, if if I choose kind of a different color here just to review the concept, if I was adding 1/2, oh, and 2/4, I wouldn't be able to add those if I was adding them. I wouldn't be able to add them until I got the same denominator. You might recall from last week. And so I'd look at those two denominators and I'd go, okay, what's the smallest number they both go into? And it's 4. And I would go like this. And I would go like this. They both go into 4. The denominators do. The bottom numbers do. Okay. And that's what they call the LCD, the lowest common denominator that they both multiply into. And then you go, well, 4 goes into 4 one time. So 1 times 2 is 2. 2 goes into 4 2 times, so 1 times 2 is 2. All right. Then you would add, okay, in review, you would go, okay, I can now add, because the rule in adding and in subtracting fractions, the rule is you can't do it until you have the same denominator. But once you get the same denominator, you are ready to add or subtract. Okay, that's the rule. It's the same for both. So at this point, I can add them up and go, oh, that's 4 over 4 because 2 plus 2 is 4, and anything on top of itself equals 1. So that'd be the answer. Okay. In the example, I have number 1 here on the screen here. I know that, hey, I've got the same, I'm subtracting. And again, I would encourage you to make things vertical like I did over here in this problem here, rather than horizontal. This example here will be simpler to comprehend because it's got the same denominator. So I could go, okay, well, 5 12s minus 112. There's two, they both have 12s, so there's my common denominator. And then I could subtract 1 from 5 and get a 4. And then I would look at that and go, can that reduce? And I know that that was a question. Hi, Buzzy. Welcome. Go ahead, turn off your camera and your microphone. Great to see you. Yeah, thank you. Nice to see you. So I would look at these two and go, hey, 4 goes into both the top number and the bottom, the numerator and denominator. So 4 goes into it once, 4 goes into 12 3 times. All right. Now, looking at the next example down, using that principle of what I just did, can you see if on your own you guys can try to do number 2 and 3, and I'll help you with 4, okay? See if you can figure out based upon what I just did. Now, hint, I subtracted my numerators once I had the same denominator, okay? Okay, I'm going to jump in here. So I'm looking at number 2 here, and I've got 5 ninths minus 2 ninths. I have 9 as my denominator in both cases. So I can just bring down the denominator because we have the same denominator now. And then I subtract my numerators. 2 from 5 is 3 here. And the last question I ask myself is, can I reduce? And again, because I got times tables now in my head, I look at 3 and 9 and I go, oh yeah, I know that 3 goes into itself once and it goes into 9 3 times, okay? So that would be my final answer, reduced down. Number 3 here, I got 4/13 minus 1/13. Oh, right now I got the same denominator. I'm ready to subtract. Bring down my 13. Subtract my numerators. 1 from 4 is 3. Ask myself that last question. Can I reduce? And no, nothing really goes into 13 because it's a prime number. So that's as low as it goes. Okay. All right. Looking at number 4 here, these are what we call, if you remember, these are what are called mixed fractions because we're mixing a whole number 8 with a fraction. And it would be said out loud 8 and 6/7. The one below is 5 and 2/7. See that word and there? So I'm going to go ahead and subtract. Well, first thing I'm going to do is look at the fractions and ask myself, is this fraction up here bigger than the one down here? Is it larger? 6 out of 7 pieces, that's almost the whole pizza. 2 out of 7 pieces, that's smaller. That's way less than half. So yeah, this one's bigger. So I'm not going to have to borrow. We'll get into that more in a moment. So I'm going to subtract 5 from 8, 6, 7, 8. I'm going to look at my common denominator, just bring it down. And I'm going to subtract my numerators. 2 from 6 is 4. And then the last question I'm going to ask myself, everybody, is can I reduce this? No, I can't. Okay. So in review, the rule is you got to have the same denominators, okay, before you can add or subtract fractions. And all right, so let's take a look at another example. If I can get this thing out of the way here. All right, subtracting fractions with different denominators. Okay, so go ahead and take a minute or two just to relax and copy this all down. All right. Hopefully I'm not rushing you too much here. Number 1, you've got 5/8 minus 1/3. And so you're looking at that denominator and you're going, didn't Tim say the rule is you got to have the same denominator? And we don't. So you're going to do this. You're going to write an equal sign and an equal sign. And you're going to look at those two denominators. And you're going to ask yourself, what's the lowest number that they both multiply into? All right. So I'll start and look at 8. Does 3 go into 8? No. Double 8. 16. Does 3 go into 16? No, it doesn't. It goes into 15, but not 16. And then 8 times 3 is 24. Do they both go in that? Yeah, there's your lowest common denominator right there, 24. 24 and 24. Now you ask yourself, okay, what did I multiply the 8 by to get it to 24? I must have multiplied it by 3. So whatever I did to the top, I got to do to the bottom. Bottom, I do to the top, excuse me. This becomes 15. What did I multiply 3 by to get it to 24? Must have multiplied it by 8. So I'm going to do that to the top here, and I have an 8 here, okay? All right, now I'm subtracting here, so I'm looking at my same denominator. I am ready to subtract. So what I'm going to do is just go ahead and subtract, bring down my 24. 8 from 15 is 9, 10, plus 5 is 7. There's my answer, 7 over 24, okay? That's a 4 there. All right, I'm going to give you a moment to copy that, and then we'll go into the next one. All right, let's go to number 2 here. It's a nice, it's not a real hard one. I'm looking at 3/4 minus 1/2, okay? And I recognize I have different denominators. So I just quickly am on my paper, I just gonna put I happen to know they both go into 4. That's my lowest common denominator. But I put the equal sign here like this. And I chose 4 because 4 goes into 4 itself, and 2 goes into 4. That's my lowest common denominator. 2 times, I look at that 4 there and I go, okay, 2 times 2 is 4. That's how this 2 times 2 equals 4. So I got to multiply 1 times 2 and get 2. Okay. 4 times 1 equals 4. So 3 times 1 equals 3 here. Okay. 4 times 1 is 4. So 1 has to be multiplied by the top. Now, I'm going to look at my two fractions. Yes, I have the same denominator. I am ready to go ahead and subtract. So I'm going to subtract. I'm going to bring down my 4. And sorry, things got a little crowded here, by the way. 3 minus 2 is 1. And there's my final answer. Okay. Give you a moment to copy that. Because like I said, I really want you to have a number of examples all written out of notes so you can look at the examples and go, oh, that's what I'm supposed to do here. Okay. So just so you know, I am a visual learner. And if I can see it, I remember my dad was a Boeing engineer, and he would like to give me lots of long explanations how to do math. And he would literally, I'd ask him for help on my algebra or something, pre-algebra. He'd spend 2 hours explaining all these interesting theories about engineering and why this is important and stuff. I didn't care about any of that. I just wanted him to say, Dad, I just wanted him to go, show me how to do it. All right. So finally, I would, I remember one time I listened for about 2 hours. I didn't understand a thing. Went to my sister, put down my math book and said, will you just do this problem and I'll watch? And we just work it and I'll watch how you do it. And I walked away in 5 minutes knowing exactly what to do. Okay. Visual learner. If I can see it, I tend to, oh, that's what they want. Okay. So that's what I'm trying to do with you, is be a visual teacher and give you visual examples to walk away with. So, all right, I'm looking at these two fractions here, 5/6 and 1/3. Excuse me with my pen here. The lowest number they both go into is 6. These are my denominators. Okay. 3 times 2 is 6, so 2 times 1 is 2. 6 times 1, so 5 times 1 is 5. Go ahead and subtract those, and what I'm going to get is, bring down a 6. 2 from 5 is 3. Oh, I'm looking at this 3, 6 here. That can reduce. 3 goes into itself once and into 6 3 times. Okay, let me give you a moment just to copy that. I don't want you to feel too rushed. In fact, my little eraser here, is this going to help? Maybe this will help. I don't want to confuse people. Here we go. Okay. All right. We're going to take it up a little notch here and look at number 4 here. I want you to listen to how I start thinking out loud here. I'm looking at the two fractions. I'm subtracting here. So I got to look at my two fractions and ask myself, is the top fraction greater than the bottom fraction? How do you know? Well, think of a half. Think of half of a pizza. Like this is 5. There's 5 total pieces of pizza, makes up the whole pizza. If I have 4 out of 5 pieces, I definitely have more than half, right? Because 2.5 is half of 5. So I've got significantly more than half the pizza. What's half of 9? Look at your denominator. What's half of 9 is 4.5. I've got significantly less than. So even though the pizzas might be the same size or might be cut up into more pieces down here, 9 pieces, this is a smaller fraction than the top one. 4/5 of the pizza is almost all of it. 2/9 is only 2 out of 9 pieces. So it's smaller. Because it's smaller, I'm ready to go ahead and kind of start subtracting. I'm going to do my whole numbers first so I don't forget. So 5 from 12 is 7. Notice I wrote that nice and big there so I don't forget. That's a 7 there. And then I'm looking at my denominators there, 9 and 5. They're different. So I'm going to have to take a moment here. Hang in here with me, guys. I'll tell you a little secret. There are more steps to this day than the whole rest of the quarter. Yeah, it's not going to get harder. It's actually in some ways going to get easier after next week. Well, and actually next week in some ways might be a little easier. Um, so it's just, there are a lot of steps with subtracting fractions sometimes. I'm looking at the two denominators, and I think the lowest thing they'll both go into, and again, this is where your times tables really come in handy, 45. I know that 9 times 5 is 45. I will tell you a little secret, by the way. If you're really struggling with finding the lowest common denominator, but you've kind of started learning how to reduce, okay? If you just multiply the two denominators by each other and use that answer, like 5 times 9 is 45, 4 times 2 is 8, you could use that as your common denominator. It's not the lowest one. And then when you get all finished with the problem, you'll have to reduce. But that is kind of a little workaround, just so you know that you could, I'll show you that again. I could, like in this fraction here, I could just multiply my 2 times 7 is 14, okay? To get a common denominator, even if it's not the lowest, but I would have to reduce at the end if it wasn't the lowest. Okay. A half and a fourth. I'm looking at half the pizza, only 1/4 of pizza. I can see in my brain a half a pizza is more than only 1/4 of a pizza. So I'm ready to subtract because this half is greater than this fourth. I'm going to subtract 2 from 7 and get a nice big 5 here. I'm looking at my denominators, and in my brain's just going, hey, they both go into 4. They both go into 4. That's the lowest common denominator. Give you a moment to copy that down. Now, listen how as I go through this. Notice how I put an equal sign here. It really helps if you do that, because you start visually seeing, and what am I doing there? Oh yeah, the equal means 4 times 1 got me 4. That's the whatever the denominator multiplied by to get to this denominator. I have to multiply the same number times the numerator. 1 times 1 is uno, 1 here, okay? 2 times 2 is 4, so this is times 2. So I'm going to multiply the top times 2, which is going to be a nice big 2 here, okay? Now I'm ready to go ahead and do some subtracting because I've got a common denominator, which I'll bring down. 1 from 2 is 1. Okay, and this is why I kind of said verbally a few moments ago, I'm going to write my 5 kind of big. I didn't make it real big, but I don't want to forget the answer is 5 and 1/4. It's not 1/4, it's 5 and a fourth. I subtracted the whole numbers, subtracted the fractions. They go together, 5 and a fourth. Okay. All right, let's take a look at another one here. I'm looking at 12 and a half, 8 and 3/7. I'm going to stop because I'm subtracting. I'm going to look at this fraction and I'm going to ask myself, is this bigger than this fraction? Half the pizza, 3/7. Well, what's half of 7? That's how you figure it out. You look at the denominator, which is the whole pizza. It's all the pieces. And you ask, what's half of that? Well, 3.5. I have less than 3.5 up here. Therefore, this fraction is less than 1/2. Therefore, I can go ahead and start subtracting. Okay. 8 from 12 is 4. And again, I'm modeling right, a nice big 4 so I don't forget later. I'm going to look at my 7 and 2. They both go into 14. Okay. See how I'm writing an equal sign there? I'm going to put a 14 there. I'm going to put a 14 here. And then I'm going to start asking myself questions. How did that 7 become a 14 times 2? So multiply the top times 2. 6 times 2, 3 times 2 is 6. How did the 2 become 14? I multiplied it by 7. 7 times 1 is 7. Go ahead and subtract now because I've got a common denominators. So bring down that 14 here. Oh. And subtract my whole numbers. 6 and 7 is 1. There's my answer. 4 and 1/14. Let me give you a moment to finish copying that. I figured having 6 examples like this in your notes is got to help. All right, now we're going to talk about borrowing. Okay, so take a few moments here and copy down everything you see on the slide. So let's start. I want to start by showing you a little illustration over here on the side here. Okay, if I had 29 minus, no, actually, let's do this. Let's do 27 minus 9. Okay. You guys probably remember from back when you were doing subtraction that you couldn't do this. You can't subtract a bigger number from a smaller number. And so you would have to borrow. And if I kind of illustrate this for you, you would cross out the 2, make it a 1, bring over the 1, and now you got 17 minus 9, which is 8. And then nothing from 1 is just 8 there. 1 here, excuse me. So you're kind of familiar with the idea of borrowing, that if the number on the bottom is greater than the number on top, you got to cross out the thing next to it and borrow a 1. Okay? Well, that's exactly what we'll do with fractions. Okay? And that's why I kept saying, okay, listen to me carefully, talk out loud here. So if I take, I'm going to do for the sake of simplicity, I'm going to start with, well, I wanted you to see what it looked like here. If it was written horizontally like this, that you might look at that and go, teacher, what in the world do I do with that? Okay. Here's what you do with that. You rewrite it and go, that's 9 minus 6 and 3/5. Okay. That's how you start. And then it becomes a little bit easier to start thinking about what to do next. All right. Having said that, so you see I took 9 minus 6 and 3/5. Now, if I'm looking at this 3/5 fraction, it's greater than the fraction that's up here. There's no fraction up here. There's no number here. So what I have to do is I have to ask myself, okay, I need to borrow something so I can subtract this 3/5 from a fraction. I'm going to cross out the 9, just like I did over here in this other problem, crossed out the 2. I'm going to make it an 8. And this is the real important thing you want to listen carefully about, which means we're going to pause and go over here on the side and talk about a concept that I've mentioned before, but you need to see it again here. If you've been listening, if I ask you, what does that equal? 2/2. You might remember, oh yeah, Tim said that anything on top of itself equals 1. 2 out of 2 pieces is the whole piece, pizza, okay? That equals 1. 7 out of 7 equals 1. 5/5 is the same as 1. Do you guys have the idea here? All right, so anything on top of itself is the same as the number 1. Now, let's see what I do with that over here. I crossed out my 9. I made it an 8. I'm going to bring over a version of 1. Pause in here. A version of 1 that would allow me to have the same deno here, same denominator. Okay. What would you pick? I would pick 5/5. Okay. And why did I do that? Because of this 5 right here. I'm thinking, hey, if I pick the version of 1, 5/5 is 1, that I borrowed from here, I'm borrowing 1, I'll have the same denominator. Now I'm ready to subtract. So I've got 5, this is my denominator, so I'm going to bring down the 5 here. And 3 from 5 is 2. And 6 from 8 is 2. There is my answer. 2 2/5. Sorry, everything's so squeezed together here. I'm not sure why, but 2 2/5. Okay. Let me do it again. Sometimes this is when you need to see it and hear it, follow it a few times. All right. So let's go ahead and do this. I've got 12 3/7 minus. I'm looking at that minus here. I'm going, okay, before I do anything, is this fraction greater than this? Because you can't subtract until you have the number on top is equal or greater. 3 out of 7 pieces, half the pizza. No, not even half. That's less than half. Okay. 6 out of 7. Yeah, that's greater than half. This is a greater fraction. I'm going to have to borrow. Okay. Again, think about half of the denominator. Think about half the denominator. What's up there? Is it more than half? That helps you see visually whether the fraction is greater than the one above it. I'm going to cross out the 12 and make it 11. Okay. Then, by the way, if you want to right now, since you've now borrowed, you could go 8, 9, 10, 11 and write a nice big 3 here. Okay. So you don't forget the whole number. All right. Now, this is again, this is where it's getting to some steps here. Okay. I'm going to bring over a version of 1 to add to 3/7 here. The version of 1 I'm going to pick because of this 7 right here is going to be, I'm going to add it to it like this. I'm going to go 7 over 7. Okay. Give you a moment to copy that. I'm going to add the version of 1 I'm bringing over from 12. I'm going to cross it out, make it 11, bring 1 over. I'm looking at what I'm adding it to because of this 7 in the denominator. I chose 7 over 7. Now, from here, I'm going to go, okay, I could go ahead and add my denominator, add this up. 7 plus 3 is 10. And then 7s. This is the same denominator for both, right? This is what I tell my students to do at this point. Okay. Slide the 6/7 over. Okay. Just draw an arrow here. Slide it over here. 6, 7. So it's underneath it. So it's clearer what you are doing. Same Dino. I'm ready to subtract. Put a 7 down here. 6 from 7 is 4. Last question. Can this reduce? No. Circle my answer. Okay. I'm going to give you a moment to copy that. I'd kind of like you to try on your own number 4. We'll skip 3 for a moment and see if you can just do 4 on your own. It's very similar to the number 1 here. See if you can do that. I'll give you a moment to try it, okay? Okay. I hope I've given you enough time to give it kind of some thought here. So I'm looking at 8 minus 5, 6. And by the way, if this is written sideways like 8 minus 5, 6, okay? You could do what I do. Take it and make it vertical. Look at this missing fraction up here and go, oh, I need to borrow from the 8, make it a 7. The version of 1 that I'm bringing over, because of this 6 right here, I'm going to choose 6 over 6. Because that is 1. Same as that's the 1 I'm borrowing from the 8. Now I have the same denominator, so I can bring it down. 5 from 6 is uno. And then don't forget your whole number here. There's nothing subtracted from the 7 left over, so I'm just going to bring it over here. Okay, 7 and 1/6. Okay, let me show you something else here. I'll erase this so it doesn't get in the way here. We are kind of now getting into what do we do if we have, there's a lot of steps to this, right? It seems like a lot of steps. Hang in there, guys. Hang in there. Like I said, We're looking at the most complex concept of the whole quarter. So I'm looking at 8 1/3 minus 4 3/4. I'm going to look at those two fractions. 1/3 is less than a half. 3/4 is more than a half. This is smaller. Got to borrow. I'm going to cross my 8 out, make it a 7. I could go ahead and subtract the whole numbers now. Write a big 3 here so I don't forget it at the end. Now I'm going to look at my two denominators. Okay, whoops. What did I just do here? I did the wrong thing. Let me erase this. Okay. So now I'm going to ask myself, okay, I'm bringing over the a 1, and I'm adding that 1 to 1/3 here. 1/3. You hear that word third? That is the version of 1 that I'm going to now pick. Because of that denominator, I'm choosing 3/3. This is 1 that I'm borrowing from 8. I chose this number right here. Listen carefully, because that's the denominator I'm adding it to. Okay. Someone might be asking, why didn't you pick 4/4? Because there's a 4 down here. Answer, I'm not adding to 3/4 right now. Right now, I'm adding to this 1/3 right here. That's why I picked 3/3. Okay. All right. At that point, I am ready to go ahead and add my whole numbers. So that's 4/3. And I'm going to slide this over. This 3/4 like I taught you earlier, minus 3/4. Now, this is classic. This is like, oh, there's so many steps. Yeah. This is as many steps as you're going to see. Excuse me. Now, I'm looking at 4/3 and 3/4. I have different denominators. I'm not ready to subtract yet. So I'm going to do the same thing we've been doing now for a week here. I'm going to write the equal sign here. I'm going to figure out what the lowest number that 3 and 4 multiply into. I know my times tables, so I know they both go into 12. Okay? Both going into 12. All right. 4 times 3 got me to 12, so 3 times 3 is 9. 3 times 4 got me to 12, so 4 times 4 is 16. Whatever I did to the denominator, I have to do the same thing to the top, multiply by the same number. Okay, I'm going to go ahead and bring down my, I'm ready to subtract now with this common denominators. So I'll bring down my 12. And 9 from 16 is 7. Okay. And I've got really an answer of 3 and 7/12. So I'm going to put this over here and make sure my teacher knows that I didn't forget the 3. 3 and 7/12. Let me give you a moment to finish copying that one. Hang in here, guys. Like I said, starting next quarter, you start getting to do this on a calculator. Although we'll review actually just doing it by hand, but you actually get a calculator next quarter and you can start learning to do it. And then in 76, you get to do all the math, all the fractions, everything on the calculator. And there's a couple of short videos that will show you how to do that. All right. So I want you to take a moment and practice. Just try one of these, any one of them. Give you about a minute. Okay, I hope you're doing all right here. Hope I'm not going too fast. So I'm going to go through them both a little bit more quickly so you have them in your notes. And again, I will send this slideshow to you tonight, so you'll have that as well. But I see the minus sign. Paying attention to that, that becomes a trigger to my brain going, okay, I can't subtract yet. I got to look at my fractions, 2/5 and 3/4. This is smaller. This is less than half. Half of 5 is 2.5. I have less than half the pizza here. 3 out of 4 pieces was half of 4. 2. I have more than half. This fraction is more than a half. So therefore it's greater than this one, which is less than a half. I'm going to subtract or cross out my 12, make it 11. I might as well just go ahead and do the whole numbers first here. Okay. 5. Nice and big 5. I'm looking at my numbers here. 2/5. Okay. Well, I'm going to add to the 2/5. Bringing 1 over here to add to 2/5. Because I'm adding to this number right here, I'm going to circle it. Hopefully it doesn't confuse you in your notes. Because I'm adding to that, the version of 1 that I'm choosing is 5 over 5. Now, I can go ahead and add 2 plus 5 is 7. And the common denominator, 7/5. 3/4. I can see I have not enough space, but 3/4, I would slide it over here. And I'm going to just take a moment here, guys. I think I could try to squeeze it in here, if you guys will forgive me. Looking at 7/5 minus 3/4, okay? And that means they have different denominators. So I'm going to say, okay, well, 5 and 4, lowest number they both go into is 20. I know this because I know 5 times 4 is 20. Okay. 4 goes into 20 5 times. So 3 times 5 is 15. 5 goes into 20 4 times. So 7 times 4 is 28. I'm ready to subtract because I have a common denominator. I'll put down my 20 over here. 15 from 28 is 13. Okay. So my answer is 5 and 3/20. And the last question I always ask again is, can I reduce this? No, that's a 20. Okay. All right. I hope that didn't confuse you, that this kind of went this way. I moved it over here to make it closer to the 3. I mean the 5 here. 25. Oh, I'm adding here. Oh, I don't have to worry about borrowing. So I'm just going to add 25 plus 6 is 31. Making it nice and big here. Got to get a common denominator. I'm looking at 2 and 7, and my brain is yelling 14, 14. Please use 14, 14. All right. Sounds like a robot from a sci-fi movie. 7 times 2 is 14. So 4 times 2 is 8. 2 times 7 is 14. So 1 times 7 is 7. I can bring down my 14 because I'm ready with the same denominators. 8 from 7. I messed up. Ah, this is, no, I didn't. I'm not subtracting, I'm adding. So 8 plus 7, okay, is 15. Now, this is a good example here. I want you to pay very close attention to this little twist because you'll run into this a bunch of times here, okay? So notice I added my numerators, okay, because we're adding here. That's all I did was add them. See that? That's an improper fraction we learned because the numerator is greater than the denominator. We change an improper into a mixed by dividing the denominator into the numerator. 14 goes into 15 one time. There's 1 left over and over 14. Now, here's where some students make a big mistake. They think, oh, I worked really hard on this and I got all the way to this and I turned this mixed into that. I'm all done. Okay. The 2 common mistakes I've seen in this level class is students will think they're done right here because they got a fraction here and they got this. They'll forget to pay attention to, is this a proper fraction? No, it's improper. We have to turn it into a mixed. Now, don't forget that this 31 needs to be added to my 1 over here. 31 plus 1 is 32. I'll just change this into a 2 here artistically. And the last question, and my eyes are always going to that fraction and asking myself, can that reduce? Okay. Let me give you a moment or two to copy all that. Hope you guys are doing okay. And I will take questions at the end of class for those that are kind of going, hey, I got lost here or I'm still not getting something. I will, when I pause this recording, give you a chance to ask and we'll go back. All right. I'm going to move on to the next slide. We're going to do a couple story problems, and I want to kind of remind you of a couple of the rules that I've taught you, okay? Rule one is put the numbers on the page, okay? Your numbers on your paper. All right. That is rule number one in story problems. Sometimes it just helps to take the numbers out of the story problem. But then rule number two, I'll put it over here. I think I'm going to win a national championship for penmanship here. Looking at how I'm writing here. Just joking. All right. Rule number two is keywords. We're going to look at keywords and pay attention to those, especially in the sentence that has a question mark. It's really important. It's a sentence with a question mark. What are the keywords? Okay. I'm going to show you a keyword that is a clue. The word remain. Well, first of all, from a board that's 38.5 inches long, cut. Okay, I'm just going to model for you. If I see the word cut in my brain, I think minus, taking away. Cut a piece 17.5 inches long. How long was the remaining piece? This word remaining means subtraction almost every single time in story problems. When you see, if it says how much is left or how much is remaining, you're looking at subtracting. So the board started off being 38.5 inches long. I'm not going to do the whole problem here, but it was 38.5. Well, it's not showing up great, is it? In 1/2 inches long. And cut a piece 17.5/8. 17.5/8. And it's subtraction. We're cutting. From here, again, I would look at my fractions here and ask, is this greater than this? No, it's actually smaller. 1/2 is less than 5/8. How do I know that? I'm looking at half of the denominator. Half of 8 is 4. I've got a numerator of greater than 4. So this fraction is over a half of the pizza. So I would have to borrow, okay? All right, let me just pick a nice bright color here. It'll show up better. Jeff weighed 166 pounds. Okay, he weighs 166. Went on a diet and lost 11 3/4. So he loses. I'm thinking, let me model this for you. Lost. That's probably meaning minus. Okay, when you lose, cut something, take something out, or you lose something, then it's less. Okay, you're subtracting. How much did Jeff weigh after his diet? So 160 pounds he started out. He lost 11 3/4. Okay. And subtraction sign. And again, as a reminder, in this scenario, I'm going to borrow from 166, make it 165, bring over, looking right here, 4/4, and then work the rest of the problem. Okay, give you a moment. Last slide here. From a 100-pound bag of cement, Fred used 44 5/8 pounds to make concrete. How much cement was left? And this is the sentence with the question mark. That's the key word. What's left? What's remaining always means subtraction. And it's the same sentence as a question mark. So that's telling you what you're doing. 100 pounds uses 44 5/8 pounds. We're subtracting, and that's how we'll do it. Okay. All right. I'm going to go ahead and shut off my recording. Give me a second here. Stop recording.